Hello, researchers. Welcome back. We're talking about graphing or displaying data now. So let's jump in. We're going to talk about a touchstone study that's going to be helping us learn statistics for the next couple of weeks. We'll talk about displaying categorical data, displaying continuous data, and then we'll just summarize what we covered. All right, Rachel Deemer did a really excellent dissertation. She got her doctorate at the University of South Dakota in 2016, and the title of her dissertation was Reading Achievement in a Dual Language Setting, an examination of characteristics representative of proficient dual language learners. Basically, how dual language works is that for part of the week, children are instructed in one language, and for another part of the week, they're instructed in another language. So maybe they get Spanish on Monday, Wednesday, Friday, and English on Tuesday, Thursday. Or maybe they get Spanish in the mornings and English in the afternoons. So it's kind of like half immersion in another language. So let's talk about starting the analysis phase. After you collect your data, you begin to analyze it, and the first step of analysis is to explore the data. Exploratory data analysis involves graphing the data, which is this lesson, and calculating measures of central tendency and variability, which this says later lessons, but you've probably already watched those videos. So recall our four scales of measurement or types of data. They were for categorical data, there's nominal, which is just names, right? And ordinal, which where there's some kind of order to our categories. There's for continuous data, there's interval where there's equal space between a number larger than seven of levels of measurement, right? And for ratio, that's a true zero, where four is actually um, twice as much as two, for example, because there's a true zero. Okay, so these different types of data are displayed using different types of graphs or plots, and the most commonly used types of graphs for quantitative research are the pie chart, the bar graph, the histogram. Those three are your top three. For statistical analysis, stem and leaf plots, and box plots. And then you also use, particularly for continuous data, line graphs and scatter plots. Okay, next slide. Okay, so let's talk about Rachel's data file. Her data is listed in an Excel file. That was the starting place. Each row represents one student and each column represents one variable. So her data file looks like this example here. Let's say the first variable is grade. Each row is one student. So that first student is in first grade. Gender is one. We don't with the code book we don't know if one stands for male or female. Home language, again, we would need the code book to know what number four is. ELL status, whether they're an English language learner, we need the code book to know what two is versus what one is. Whether they're in a dual language setting, now this I remember. Zero meant that they were not in a dual language setting, and one meant they were in a dual language setting. Their reading scores in the fall, and their reading scores in the spring. Okay, for that student. So in Rachel's study, she analyzed data from students in grades kindergarten through fifth grade. We'll start out analyzing data from grades first and second. So what scale of measurement or type of variable is grade? Hmm. Hmm. Grade. If you said continuous, you are right. Grade is a continuous variable. Now we're only looking at two grades though. For the first and second graders, we see that there were 143. The count of grade, the count of samples that we have were 143 first graders and 155 second graders for a total of 298 students. So almost 300 students. We because we only have two categories, it's really more like it's nominal or but ordinal because two is more than one, right? So there is an order, but we're going to treat it as categorical because there are so few. And remember, I gave you that rule of thumb that less than seven or so we is categorical. We have more than seven, then we could treat it more as continuous, or so around thereabouts. Okay, so for nominal variable with only a few categories, pie charts give a clear representation of the percent of observations of people, events, or objects we're studying. In this case, it's students that are in each category. As although grade is generally treated as ordinal, okay, because there are only two grades represented in our data set, we can graph it like we would for a nominal variable with just a few categories. So if we did a pie chart in Excel for grade, it would look like this. You see, there's almost the same number of first graders as second graders, and we can see that because our pie looks like it's just about cut in half. And I like to put the actual percentage on the pie chart of what we're graphing. And you can either put a legend or label the slices of the pie for what category you're talking about. Now, for a nominal variable or a ordinal variable with many categories, nominal variable with many different groups, or an ordinal variable with many levels, a bar graph can give a clear representation of the number of observations that are in each category or at each level. The first and second graders that Rachel studied spoke a variety of different languages at home, 10 in total. So there's a very diverse district that she studied. Here's a table that summarizes how many students spoke each language at home. Okay, so we have, here we can kind of see what the codes are, right? So one was English. What was four? Four was my. Okay, and we see that all of these different languages are represented. It looks like Spanish, English, and Oromingna are the three most common languages spoken in this group of students. I wonder where Oromingna is from. Where's my... Sorry, I'm just so curious. Oromingna. I know she was in the Midwest. I wonder if it's a Native American language. Let's see. Afro-Asiatic macro language. Uh, like Arabic. Where is it spoken? It's spoken in the Horn of Africa. I wonder if in this Midwestern area they had people who had come from Ethiopia. Interesting, interesting. Okay, so they must have had a group of African immigrants, recent African immigrants in that school district. Okay, so let's see. Continuing on. Here's a bar graph in Excel for home language. Notice that for this bar graph, each bar represents the frequency or number of observations for each category. So you get the number of students, English, Spanish, Armenia. Okay, the frequency. This bar graph represents the frequency. I have a title on my graph. I've labeled my y-axis. There's no label on my x-axis. It's kind of explanatory because the title says home language. This whole title should have been the label on my x-axis, and the title should have been the number of students speaking each language, or home language for, no, it's the number of students speaking each language. And because these are the home languages, right? Okay. So this graph is not perfect. It is clear. You can see the number. There's a label with the number for each, so it is clear in that way. The labels underneath each of the bars actually show the name of the language, so you don't have a legend, which might get kind of awkward with 10. Um, so that's clear. I would put home language here at the bottom though, and have something about the number of students um, in the title. Okay, let's talk about continuous data. When we collect a large amount of data, it's very difficult to make sense out of it without plots or graphs and descriptions of the score distribution. So let's say we had test scores from 50 people. And if we just listed them all out, if I told you, okay, the first person scored 21, the second person scored 95, 73, blah, blah, blah. It's just a jumble of numbers, right? Not very interpretable. But what if we make a grouped frequency distribution? Okay, we're going to think of some kind of intervals that make sense. Now, for test scores going from 0 to 100 or 1 to 100, it makes sense to group them into bins or intervals of 10. So 1 to 10, 11 to 20, 21 to 30, and so forth. And then we can count how many scores fall into each of these bins or intervals. So there must have been two people scored between 1 and 10 on this test. This must have been a pretty hard test. Look at this distribution. It looks like the mode, remember that? The mode looks like that is in the interval 51 to 60. So 9 students, the most frequent um, interval is 51 to 60. So 9 students scored between 51 and 60 points on this exam. Okay. So a histogram is a bar graph of a frequency distribution. So you put the values of your data, the scores, on the x-axis, and you group the values in a way that's sensible. You use intervals or bins, not too many, not too few. You want to be able to see the shape of the distribution, and then you count, the count of how many times the frequency on the y-axis. So here's that frequency. Here's a bar graph of the frequency distribution for the data we just looked at on that table. And yes, the mode is 51 to 60. You can see that very clearly here. This graph is mound shaped. I would say it's normally distributed. Okay, it's mound shaped, mostly symmetrical. Okay, it's mostly symmetrical. Um, with the most frequent category in the center right there. So one mode in the center, pretty symmetrical. That's normally distributed. Okay, so that's a frequency distribution. So how do we describe these distributions? Now I just talked about it a little bit. Symmetry, is it the same shape on both sides? Is it basically mirror reflections of one another? Modality is the number of peaks. Okay, unimodal, one mode, one peak. Bimodal, two modes, two peaks. Okay, and they don't have to be exactly both at the same. If there was one category where there was 9 and there was a category separated from that where 8 students had scored in that interval, then I would say it was bimodal. Right next to each other, it looked unimodal to me. Skewness, positively skewed. Now we use the word skew in our everyday language. It's slightly different in statistical language. Positively skewed means that the trail is going to the right. A few high scores, right? They're mostly low scores. Let me see if I can. Mostly low scores, few high scores. The mean would be pulled up by high scores or pulled over by high scores. That's why we say it trails to the right. And I know the video this might be coming out backwards with my hands to when I'm saying right is my hand going left. Um, yes. So negatively skewed is trailed to the left. Okay, so it's trailing left or downward. A few scores pull the average down. Okay, so we'll look at some examples. I would describe A as basically symmetrical, okay? Mound shaped. A is normally distributed, okay? It's unimodal, not much skew, no skew, okay? It's mound shaped. B now, B I see two peaks, okay? And so B I would describe as bimodal. And you see how it kind of dips in the middle? It goes peak and then it dips in the middle and then there's another peak. Okay, so I would describe that as bimodal. C is definitely skewed. There's one mode, right? But you see how there are these values trailing to the right? Those values, those high values, those few high values are going to pull the mean up, okay? And so I'd say it's positively skewed. The mean is being pulled up to a higher value. D is also skewed. It's not symmetrical, okay? It's unimodal and it's skewed. These values trailing to the left or trailing down to 0 are going to pull the mean down. So we would say it's negatively skewed. Okay. So symmetry, modes, skew. Okay, let's talk about stem and leaf displays. Conceptually, stem and leaf displays can be interpreted like a histogram, but the cool thing about them is that you retain the individual values and the frequency of those values. The stem is put on a vertical axis, which indicates the range of values, and the leaves on our stem and leaf are on the horizontal axis, indicating the frequency of individual values. And you can completely regenerate the data from a stem and leaf display. Okay, you can get to the raw data from the stem and leaf, which you can't from a histogram. Now, stem and leaf displays are almost always only used in the exploratory phase of a statistical analysis. So you can make a stem and leaf display in Excel, but nobody ever does because it's a pain. But we will make them when we are using SPSS. So here's an example of a stem and leaf display. Looks like there were 300 participants in this study. RX time sounds like reaction time to me. The leaf unit is in tens, so this is probably 36 seconds is the first, the reaction time of the first participant. 37 seconds, 38 seconds, 38 seconds, 39 seconds, 39 seconds, 39 seconds. Okay? See that? And then, let's see, we've got 40 and 40 and 40 and 40, then 41 and 41 and 41, and then 42 and 42 and 42, 43, 43, 43, 43, 43, and so on. We know this is in tens, so it has to be 30, 40, 50, 60, 70, 80, 90, 100. And I'm guessing that it's in seconds. And so it's the stem is in tens and then the leaves are in ones. So that's why it's 36 is the first score, the first time. Okay. Stem and leaf display. You'd use a stem and leaf display when you take a first look at your data and to make sure that your distribution is normal. So if we look at this and it's sideways, right? It is symmetrical, okay? And it's basically mound shaped, right? Sideways, symmetrical, basically mound shaped, okay? So we got a normal distribution there. And that way you know what statistics to use. Now, how does a stem and leaf display differ from a histogram? Well, one thing is the orientation, right? The stem and leaf display the leaves or bars are going horizontal, whereas a histogram, normally the leaves or bars are going up or down. A semi-leaf display gives you more information because you know what each value is. Okay. Stem-and-leaf display is not as commonly used as a histogram. Bar graph is our next one. Numerical information about a category is represented by, by the height of the bar, right? And each bar represents a different category. So for example, let's say we had a sample of ACT scores and we were looking at the average ACT scores in this sample. It looks like the students did best on the reading test. That has the highest bar, and they did the worst on the English test. They can read it, but maybe they don't know their grammar and syntax as well. Um, with math and science in between. Okay, so we had four categories of ACT tests, right? And these categories of tests are nominal because there's no natural order for them to be in. And then we can see what the average score. Now we're not counting the number of participants, right, in each category. We're not counting how many students took each test. We're we're graphing the average score. Okay? So this is not frequency on the x-axis. It's some statistic. All right. So we've been talking about what you use for categorical data, like um, the bar graph or the histogram. Let's talk about if you have two continuous variables, you would use a scatter plot. And this is something that we'll make scatter plots in SPSS. You can make a scatter plot in Excel as well. A scatter plot shows individual data points, for example, a dot for each participant in the study. It can show the relationship between two continuous variables, and it's essential for quantitative analysis. Okay, essential. The first thing I do is make box plots and scatter plots. Okay, and so let's say we're looking at the relationship between exam anxiety and exam performance, right? So we have anxiety here on the x-axis going from 0 to 100. They filled out some survey asking how anxious are you? We have performance going from 0 to 100 on the y-axis. We did the survey. There was a person who was like, I'm not anxious at all. I got this. And so they scored 0 on the anxiety scale. There was only one person who scored 0 on the anxiety scale. And look at this, they scored about 90 on the test. So they weren't anxious, they scored high in this sample. Same thing for this person who scored only about 10 on the anxiety scale. They scored 100 on this exam. Okay? And then you have a large cluster of folks who were scored between 80 to 100 on the anxiety scale, and their scores were all over the place. You had some people who scored high on the anxiety scale who were also high in terms of their exam performance, and then you have a bunch of people who scored high on the anxiety scale and were low in terms of their exam performance. Okay, so you see how that worked with the dots? And then someone has thrown a line on top of this showing the if you were to figure out a kind of a linear average is what this line is showing, a linear average at each level of anxiety. And you see, yeah, if when anxiety is low, on average the scores are higher. When anxiety is high, you get some high, some low, so the average score would be somewhere in the middle. Now, for a line graph, and we see line graphs all the time, right? They're all over the news, they're, in the paper, that kind of thing. We see line graphs all of the time. For a line graph, there's one value of y for each value of x, and it can be used to show the average or typical values of an outcome at different levels of the predictor. So My first baby was a little girl. I was constantly worried, is her weight normal? Is she growing right? All this kind of thing. And so here's um, the type of graph that can either fuel or dampen parental worries about the weight of their child. So here's age in months, so 0 months to 25 months old, and then weight in pounds, 0 pounds up to 30 pounds. So let's see. A 2 year old would be about 24 months, and we would expect them to be around 25 pounds. And at birth, we would expect a baby to be around 7 pounds or so, right? On average. Okay. At 0 years old, my baby girl was 5 pounds 10 ounces. So she was a little below average, but she's since made up for that. All right. So a line graph. One value for y for each value of x. So you get these dots that line up and then they can be connected with a line. So which graph would do you use in different situations? You're going to use a pie chart when you're going to display the percent of observations in a small number of groups. I'd say, should we stick to the number 7? Is that a good rule of thumb? 5 to 7 or less. Okay. A bar graph display the numerical information about categories or about ranges of a continuous variable. Okay, ranges or intervals. Histogram, a special type of bar graph used to show frequency, how many values fall in each range. Okay. Stem and leaf, used like a histogram, but it retains all the individual values. Scatter plots display information about individual data points for two continuous variables. And line graphs display summary information about continuous variables. And we talked about box plots already, I think. Yes. And so that's it. All right. So there's your information on how to display data. Okay. Bye.